This is 2.5 for Algebra 2. We're talking about correlations. So the numbers 1 through 3. Sorry, I gotta grab something here. All right, numbers 1 through 3 tell whether x and y have a positive correlation, a negative correlation, or relatively no correlation. So for number 1, I definitely see, so for correlation, you're looking like, well, is there a general line that you could kind of draw that the points are pretty close to? Not that that's a perfect line, but yeah, I definitely see like the points all tend towards that line. So that is a negative correlation because as the x's increase, as we move to the right, the y's decrease. They go down in value. So this is a negative correlation. For number 2, there is no line that or pattern that these points are tending towards linearly. So there is no correlation. And for number 3, holy cow, yeah, they're all really close to something like this line right here. So there's a very strong correlation. It is positive because as x increases, as we move to the right, the y also increases. So that's a positive correlation. Beautiful. All right, so we're trying some of these out. Draw a scatter plot for the following data sets and tell whether they have positive, negatively, or relatively no correlation and approximate best line for the data. So we have 1, 6, that'd be right about there, 2, 6. Something like that, I guess. 2, 4, 6. Something seems funny about my counting. Either way. So now I need to make a line of best fit. I have this awesome straight line tool. You could use something that's straight. And I'm going to make a line and then I might have to adjust it a little bit. So the idea is you should hopefully have the same number of points above the line as you have below the line. Technically, the line that's best is the line that has the least amount of distance between the point and the line. Totally. And you add up all the distances like that. There's a little bit. Not much, not much, a little bit. Anyway, and there's computer programs that will actually make the line of best fit. But it's good for us to know how to do it, and then we know why or how the computer's doing it. So there's my line of best fit. Now I need to find 2 points that lie on the line, and those 2 points that I use do not have to be data points. They just need to be 2 points that I can find the exact coordinates of. I wonder if my line should go up a little bit. Whatever. This is probably good enough, right? All right. So I'm going to use a different color. But like right here, I know this is, I better count it out, 2, 4, 6, 7, 7, comma 2. That point lies on my line of best fit. It's not a data point, but that's okay. And then, you know, this is pretty good right here too. That actually, whoa, that actually is a data point. It's 2, comma 2, 4, 6. 2, comma 6. So now I'm trying to write the equation of a line. It's my black line of best fit. And I'm going to use these 2 points for my line of best fit because those 2 points are 2 points on the line. So let's find the slope first. So m equals, let's go 2 minus 6 divided by 7 minus 2. I get negative 4 over 5. Here's a good thing to check, folks, in case you accidentally subtracted the wrong way or made a mistake. I realized that this is a negatively sloped line. So the slope that I calculated is also negative, so that's good. Now I use one of those coordinate pairs. I'm going to use this one. So y is 6. I'm plugging that into slope-intercept form. I know the slope. I know an x and a y. I can calculate the y-intercept, although it looks like it's about 2, 4, 6, 7 and some change. So hopefully my math shows that. So the slope is negative 4/5. That goes in for m. I'm going to multiply it by 2. And so I get b equals negative 8 over 5. So I'm going to add 8/5 to each side. So I get 7 3/5 because 8 and 8/5 is the same as 1 3/5, and then I add that to 7, gives me 7 3/5. That's what b is. So the equation of my line is negative 4/5 x plus 7 3/5. And again, I like the 7 3/5 because it looks like it's between 7 and 8. It actually looks like it's a little bit closer to 8 than 7 3/5 would be higher up than halfway. I emphasized my line a while ago because this is a good, I think this is an accurate line that represents the data. However, this is not the only line that represents this data. So if your slope is a little different, or your y-intercept is a little different, that's okay. All right, let's try another one. Whoa. I'm gonna start plotting them, and then I'll start talking. Okay, so one thing I'm going to talk about right now is the fact that 7.2 is kind of annoying to graph. So just do your best. And then I got 6.4, so I'm going to try to go a little bit under halfway. 0.6. So yeah, that's just do your best. 1, 5.5, 2, 5. Ooh, you know what? I think I forgot to ask. So tell her they have positive or negative correlation. So this is a negative correlation. And I'd say it's a pretty strong correlation. Like those points all seem to fit really close to that line. Very close to that line. So it's a negative correlation because the slope is negative. And then, yeah, strong correlation because they're close to the line. Here, I'll make a line. There's definitely a negative correlation. You can almost just see the line. I mean, I'm going to make my line go as long as possible, but I'm really just looking at, yeah, that's, okay, let's call that good enough. So there's my line. We have negative correlation. I'd also call this quite strong. The points are all super close to that line. So then I'm going to use this point right here that's at -2. Oh, that's not actually at, doesn't quite, I think I can find a better point because I'm not sure that actually hits 7. I think it's a little bit higher. I'm staring at my laptop right now. My face is about 2 inches away from it. It's probably not good for my eyes. Oh, geez. I'll lose all my eyesight. That's really scary. I'm just going to use that one. I'm not very happy with that, but 2, 4, 6. I couldn't keep sacrificing my vision. 3, 4. All right, so those 2 points are on my line of best fit. So now I just need to calculate the equation or write the equation of that line of best fit using those 2 points. So find the slope, rise over run, so 4 minus 2 on the bottom, subtract the x's in the same order, so 3 minus 6, I get 2 over -3, move the negative sign up to the top. This is a negatively sloped line, and yeah, it looks like I'm dropping, ooh, whoa, Mr. P, I said move the negative up to the top, don't move the numbers. It's funny, I usually don't check that or emphasize that, but as I go from this blue dot down to the green dot, I'm dropping 2 and going 3. Good thing I double checked that. So now I use a coordinate pair and the slope and plug it into slope-intercept form to get a beautiful equation of my line of best fit. I'm going to use 6, 2. I just like using even numbers. I don't know why, but so my y is 2. My slope is -2/3. And my x is 6. That's actually nice because 6 is a multiple of my denominator, so that means I get rid of the fraction. So I get -12 over 3. Take 6, multiply it by -2, which is -12, and then divide it by 3. So that is -4. And then, oh, that looks messy. And then solve for b. So we're going to have to add 4 and add 4. And b is 2 plus 4 is 6. And look! What is my y-intercept? It's 6. Oh, that is beautiful, isn't it not? I mean, I'm sorry for sounding goofy with it, but it is cool. folks. So my slope is negative 2/3 multiplied by x. The y-intercept is 6. Hooray! Last one. -2, -6. So definitely a correlation here. It's a positive correlation. As x increases, so does y. Straight line tool, hello. Make a straight line. Boy, that's not too bad. Probably should go up just a hair. I'm gonna call that good. I mean, there's 4 dots above it, but it's super close to those 4 dots, and it's a little farther away from the 2 dots on the bottom. So I'm gonna go with that. So then, boy, it's like it's a slope of 1, and it's just below that stinking thing. God darn it. I don't know. I'm gonna use this point. Oops, I want to make it a different color. So I'm going to use this point right here at at 2, -2, 2, -2, and then yeah, I'm going to just use that. That's at 4, 0. So here we go. 0 minus -2, 4 minus 2. 2 over 2. Sure enough, it feels like it's a slope of 1. That's what our slope is. So now substitute in the slope and 1 coordinate pair. Just use 1. I'm going to use 2, 2. Oops, that's 2, -2. Ooh, that could be a big mistake. -2 for the y, 1 for the slope, times 2 for the x. Simplify and solve. Simplify means clean up that right side. 1 times 2 is 2. And so now I'm going to subtract 2 from each side. Oops. So subtracting 2, I get -4 for b, which, oh yeah, look at that y-intercept. It's -4. So the equation of my line is y equals 1x, or just x, minus 4. Boom. That's the equation for my line of best fit.